and all, and eventually you have to work with AlgoKit, right? So I'll just showcase some things over here. Just give me a moment. Okay, so I'll just open PowerPoint to let you know what we are going to have. So if let's say AlgoKit is the one which you are going to use, and in order to consume AlgoKit, Mudassir, my screen is visible, right?
Yes, sir.
So in order to consume this AlgoKit, what happens over here is you have to first install Python, then you have to install Docker, then Git for Windows. Don't install GitHub like directly that GitHub desktop and all. You have to install Git for Windows. It is a special utility which allows the Windows or the GitHub Bash integrated with your terminal. So Git for Windows, and then ppax, and ultimately AlgoKit, right? So these are the steps required. There is a complete AlgoGAN session around how to install AlgoKit on your machine. You can get, if you face any problems, you can just go ahead and look at those videos. Then ultimately, as an editor, we are going to use VS Code. Why VS Code? Because VS Code is a very lightweight editor, which allows us to manipulate or to create the platforms, or to, sorry, not the platform, but to create the solutions around plenty of languages in the world. And that's why it is a popular choice around nowadays around developers community to use VS Code as an editor. So this basically is an editor. So once you utilize AlgoKit, or once you install everything and AlgoKit starts working, then something like this you can check, right? So over here you can type your terminal, open your terminal or your command prompt, and you can just type in AlgoKit -- version. Once you do that, you will be able to see the version 1.1 11.2. Currently I guess it's 1.11.4, but I have not updated that right now, so that's why it is 1.11.2. Now basically the question is, what is AlgoKit, right? Now since you guys are pretty new in the blockchain world, or even in the domain arena, so my in the development domain, so what is AlgoKit basically? So AlgoKit you can consider is an SDK or software development kit kind of thing, right? So Mudassir, what do you think? Why SDKs are required?
Basically, so that we can consume their utility function libraries and build our own solutions.
So basically faster development. Why? Because then the pre-built libraries are there, or predefined libraries are there, you can consume. So faster development, consumption of libraries. Okay. So basically these two couple of things which will enable you to quickly go to the market without removing or without having a or reducing the learning curve. Now, what is a learning curve? So guys, this is a very, very important topic in the development world, because when you talk about any platform, let's say tomorrow you are going to do a job. Now when you are hired as a blockchain developer, and then you are asked to that, okay, in what platform or whatever you are going to develop on, what platform you are going to select and all, hypothetically this learning curve plays a very important role over there. Point is, if you are not aware of that platform and the learning curve is almost a month or so, it will hamper your delivery dates. So over here also, when you are adapting a new technology, and when the proper SDK is there, then that entire learning curve can be reduced minimal. Why? Because then pre-built libraries are there. You just read the documentation and you are good to go. And what is the main thing is, with the use of SDKs, that you don't need a separate language, right? Similarly, on other platforms, you are supposed to learn various different languages in order to develop all those blockchain platforms, right? But over here, the development happens in Python, which is anyways known to most of the people, most of the students nowadays in India, as it is now taught in the schools also. So Python, you can code in Python. The second one is you can use TypeScript. Basically, we call it TillScript. It's an extension of TypeScript, and you can utilize that. But the point is, then my question is, what is Till, right? So yesterday, Mudassir, have you discussed about the AVM
No, I will cover like today.
today? Okay. So when you cover that AVM today, Algorand virtual machine, just try to, okay, guys, I'll just brief you about what is a virtual machine. So when we talked about the first blockchain implementation, which was known as Bitcoin, right? So I'll just have a different thing over here, different slide. So over here, virtual machines, let's say, or AVMs. Now in Bitcoins, if you know, Bitcoin was the first blockchain implementation or first cryptocurrency, right? Do you think that Bitcoin runs over a VM, Mudassir?
No,
No. So there is no VM associated with Bitcoins. Why?
because it's Turing incomplete.
Yeah, the language supported is Turing incomplete. So basically no VM. Why? Because it's a very basic assembly language kind of situation. That's why Bitcoins does not require a VM. But Algorand requires a VM to run. What is that VM called? It's called AVM, Algorand Virtual Machine. Why? Because Algorand supports smart contracts. And Algorand is a programmable blockchain. So in order to execute those smart contracts, you need a medium. That's where your virtual machine comes in the picture. So in that virtual machine, your program gets converted to TIL basically sort of a bytecode language for the processors to understand, and then they will execute the code which is whatever is defined in that TIL, and your smart contract gets executed on your blockchain platform. And that's why the platforms which support smart contracts, or you can say dynamic programming languages, they will have VM of some sort, while the platforms which don't have any sort of extension of programming, they will not require virtual machines, right? So that is basically Algorand virtual machine. Once you install Docker, you will be able to see this kind of situation over here, Algorand sandbox environment. And in that sandbox environment, you will be able to see four different items. One is your Postgres, that is your database. The other is your Algo D node. Algo D node is basically your main node. And then your conduit, which is basically your event management system. And then ultimately indexer. Indexer is basically where, as I told you, that Algorand, a blockchain is a ledger. So chronology is very, very important. And that chronology is maintained by this indexer node. And all the transactions are managed by Algo D node. So basically, since yesterday only you have started blockchain, so main network, I can tell you that Gmail is kind of your main network, and your email, your personal email, whatever your email is, becomes basically your separate or your own version of Gmail. So over here, your Algo D is a main network node where every transaction can happen, but individually, where whenever you make a transaction from your wallet, that becomes your transaction. Right? Currently, there are three environments over here which are supported in Algorand. Like so, first is your sandbox environment. Sandbox environment basically it's you can say local to your machine or PC or laptop or whatever you want to call that. But then we have a test network, and this test network is global. Global means it is hosted over the cloud, so anybody can access. And then we have main network. So main network is basically your original money is involved, similar to test network, but real money or fiat currency is involved. Real money involved. That is basically called main network. So test network and main network, the only difference is here we have test tokens, which is not going to cost us anything, while over here in main network, it is going to cost us, right? So over here, when we talk about AlgoKit, AlgoKit basically, when we install the Algorand sandbox environment, our default domain structure is created, but we don't need to even know that. Why? Because AlgoKit is there for us. So in order to start the local development sandbox environment in your machine, you just open your terminal and type the command AlgoKit localnet start. And immediately your local sandbox environment will be started for you. So you can see that Sandbox, Algodi, Postgres, Conduit, and Indexer. Four different nodes are four different Docker images are running for you, or Docker container images are running for you. And if you write down, as the bottom it is told you, it is telling you to write AlgoKit explore to explore local net. So I can do that, AlgoKit explore, and immediately a website will be popped up, which basically can connect to your sandbox now. And now, even though it's a website, still you are able to connect to your network. The network currently over here for you is local sandbox. Right now, if I want to, if I want to connect to your sandbox environment, no, it will not be able to possible for me to connect to your sandbox or for you to connect to my sandbox. So sandbox works only local. Now, once we do that, this particular sandbox environment, now we are connected. So at the bottom, there is a message telling you connect wallet. Why? Because in blockchain, nothing can talk to blockchain without a wallet. So wallet is basically your passport to join or to start interacting with your blockchain. So over here, when you click on that connect wallet, then multiple options are given to you. Algo signer, my algo, para wallet, defly, and dev wallet. So currently we can go ahead with dev wallet. If I go to dev wallet, so see, these are all developer wallets which are created by me on this machine, and currently over here we are taking I'm able to see that. Now I can see any one of that, or I can select any one of that, no problem, right? But what I want to do is I want to see that how many wallets are by default created with my sandbox. So when you have the sandbox environment, by default, 3 wallets are created for you, right? Whenever the sandbox environment, use start. Now, how to check all those all those sandbox wallets? So you have to type the command AlgoKit. Then the command is goal. Then the command is account, and then list. Now let us fire this command over here. AlgoKit, goal, account, and list. And you will be able to see 3 addresses over here: BCKK, BZ, FR6, and WIYI. So these 3 wallets, whatever wallets which are created for us by the sandbox environment, are given to you, right? BCK, BZ, and this one. But when you go over here on the dev flow, when you try to connect to this one, developer wallet, those 3 wallets are not listed over here, right? And we want to connect to those wallets only, not these ones. So what can you do? So go to developer wallets and then click over here, import from KMD. Now, once you do that, you can see that these wallets are now will be listed over here, and see the same 3 wallets which are over here, BCK, BZF, and WIY. You can see that all those 3 wallets are listed over here. Now what can I do? I can just add these two developer wallets, the first one, or maybe the last one, since it was used to create something. So the last one, this one, WIYI. So once I do that, what happens now? I can just terminate this flyout window, then go to dev wallet and select the last one which we just added, WIYI. If I click over there, you will be seeing that over here, your wallet address is now there. So now you are able to see whatever transactions we are going to do using this blockchain wallet address, we can see over here. Now, if you go over here, App Manager, you will see that something is created. Why? Because I was testing something before this session. So that particular application is now created with the title of 1001, or the app ID is 1001. Right? Don't ask me what about the 100,000 before. No, it starts with 1000 only. So 1001. So this is how a local sandbox environment for you using AlgoKit, which you don't need to do anything. Just write down the command AlgoKit localnet start. So even in the sandbox environment, before this, what you need to do? The command you need to write is AlgoKit localnet start, and your development environment will start. And in order to check whether which version is there, then algokit hyphen hyphen version. So over here, I'll just write down what is it for. So to check the version, over here, this is to start the local environment, local dev environment. And over here, to get the pre-default wallet addresses from sandbox, right? So that is how your algokit commands are listed. Now what is required? What was required first time? That we need a development environment. Check, we have done that. We needed an SDK AlgoKit, so now it is there also for us. We wanted to start the environment, we started. We wanted to check the wallets, we did that also. So now, as the next step is, how then? Okay, AlgoKit has helped us a lot, but then can AlgoKit create sample templates for us? Then the answer is yes. So for that, the command is AlgoKit init. Once you press that AlgoKit init, you are offered plenty of options over here, like Beaker, TiltScript, Puya, React, Full Stack, Playground, right? So Beaker basically, if you are if aware of wrapper kind of situation where a wrapper code is there or a wrapper is created for you to communicate with some sort of language at the core. Beaker is that kind of framework which allows you to deploy your smart contracts using Python to your local net, test net, or main network. Then the second one, we already discussed what is a tail script. So tail basically is a bytecode kind of language which gets executed over the Algorand virtual machine. But since we cannot code into assembly-like languages, so we need a wrapper over there, and that wrapper is called tail script, which allows you to write the code in our popular programming language, but ultimately gets executed over the AVM. Then Puya. Puya is still currently in developer preview mode, so do not recommend right now. Do not even try that. Once it is stable, then you can try. That's why it is saying that not recommended for production. And you may enter up into some certain problems and all. So I won't recommend. For the first time, you should not use Puya. So then for the first time, you should use Playground. Now this React and full stack, basically, you know that what is a full stack developer. So this is the only SDK environment which gives you not just smart contracts, but with front end and back end both possibilities and both code running. It's not that you have to do a lot of changes. We will get both the things running, right? So if you select the Playground, by default, the 6 smart contracts are created for you. And then from that, you can start your Hello World, right? Or your primary smart contract. So if you select this one, let's say Playground, and then what the first thing which is asked to you is name of project or directory. So currently, because it's a learning weekend, so I'll just say learning weekend hello world, right? Now I'll just create the directory will be created and all the necessary templates, files, folders, everything will be there. Now, because you all know that whenever Python or any other programming language is involved, then you need to install the supporting libraries also. But then how many do you need? What is the list? Or do you need to install those manually? No. So for that, AlgoKit again comes to your rescue. And AlgoKit Bootstrap is the command which will install all the necessary libraries for your project. So just type in Y and you are good to go. Then we are having, we can see that poetry. So I'm just curious, guys, that what is poetry for Python? Anybody? No one? I was told that you guys know Python. Mudassir, you can keep a track if somebody answers in the chat.
Yeah, sure.
So now you tell me, what is poetry?
It's a dependency manager, basically.
So sort of your NPM. So poetry will install all the, it's a kind of package manager which will install all the necessary dependencies for the program to execute, right? So if once you do this, then your by default, your VS Code, if you have installed it, will automatically open up. And we can see that the first folder is .venv or in popular words, it is known as virtual environment. So what is a virtual environment? So when you you can say install Python. Now Python has multiple versions. Now in order to execute Python code, you need to match the version with the libraries you are consuming with Python. And every time somebody uses 3.8, somebody uses 3.11, 3.12, 3.10, 3.9, or maybe even the older versions also. Now you cannot have these many Python installations on your machine, right? It will overlap. So what you must do is, while using Python, is you create a virtual environment and you execute that virtual environment, and in that environment only you execute your code, right? Otherwise, so that your regular Python is will not never be disturbed. Whatever libraries you want, you can install in a virtual environment, and that is, if I tell you, it is mandatory for every developer to create a virtual environment and then only execute the Python code, so that your Python environment is always stable, right? The local Python environment. So over here also it is already done. You can see that, right? There are plenty of other codes also over there. If you expand the script, then you can see that all the other things which are required, like first script I'm interested in is in activate, right? And since we are on Windows, this is the script which is being called activate ps1. And whatever commands which are going to be executed, all these commands are coming from this particular file, right? And there over here, the entire virtual environment is created, and whatever necessary things which are supposed to be required by the algo kit to run the environment or to run the code will all automatically be started using this one, right? So this is your activate ps1. You can see that. Rest of everything, we don't need to worry about that, but this is your basic file which gets executed. Now, coming back to the folder structure, if you go to the folder structure part, you will be able to see that this is okay, virtual environment. Where are my smart contracts? So your smart contracts are located under the playground folder. If you expand the playground folder, you will see ABI, blueprint, boxes, contract, to contract, hello world, and state. Now, what are all these things? No idea. Since you are executing for the first time, for you, no idea. But I know what is hello world. Hello world is entry to any programming language. So I'll just expand hello world. Now in hello world, I see three different files over here. First is hello world.py. So basically, yes, my file. And over here, we can see that there are some import statements for us, basically. Mudassir, my text is visible, or should I just increase?
It's visible, but yeah, you can just increase a bit.
Yeah, how to increase that text size? Okay, function, I guess, Windows and plus plus, right? Something or like that?
Control
No,
plus, I guess.
no. It increased, but then now I'm in trouble. Oh, it magnifier started. No. No, there is a way to increase the font size. The control plus plus or something. Yes,
Control
control
plus.
plus plus. Clear? That's it?
Yes, sir. Yes, clear.
This is more clear.
Yeah. So you can see that this is basically two import statements are given to you. And then an application is created under the title of Hello World app. Now we will change the title from here. So I want to create, let's say, Learning Weekend. Can we do that? I'm not sure. Let me try. So I'll just change the name to Learning Weekend. But then there is a function over here which is defined as app.external. Now there is a huge, you can say, you have to invest a decent amount of time and understanding that there are two kinds of functions in blockchain. One is external, the other is internal, right? So today we are not going to discuss in that detail. This is a simple Python function. You can see that definition is hello. Definition is basically the way you define or define whatever you want to call that. Define hello. Hello is your function name. Then there are, you can say, parameters. So it is accepting one parameter only, name, and which is a type of string, which is coming from your pytil ABI string. So it's just a data type coming from a class called PT. Then output. Then this particular star marks that your input parameters are over. Okay, we know that how functions work, right? You pass some parameters and you expect some output parameters. So over here, I'm expecting an output, simple, and expecting output is always, I mean, over in this case, it's a string. You can manage whatever you want to do. Here it is basically, we are returning string. Now, instead of hello, I just want to change the name also over here. So instead of hello, what can I do? Let's say hello Sunday, something like that. But then AlgoKit welcomes, something like this, right? And whatever the name we are going to have, it will tell AlgoKit welcomes and the name. Now let me save this file. So this is your smart contract file. This hello world.py is your smart contract. You can see that sample hello world beaker smart contract. Okay. So smart contract is created. First step is taken. We have even seen the wallets from the sandbox. We have imported those wallets onto app.devflow, right? So over there also we are able to now see the transactions. Cool. But then we know that in Python, whenever we write a contract or we write any sort of Python, we need to execute that Python file also. So how do I execute? So I'll go to build.py. Now in build.py, now you can see that over here from pathlib import path, that is again what path library is basically to access directory structure. There is a package. Over here, we have imported hello world. So that means this particular file which we have created, we are importing over here. Now, over here, one more definition or one more function is there, which is known as build. So what does build do? Build actually building the file or building the hello world file. So you can see hello world.app.build. And then the most important part is it creates an output directory with the name of artifacts. So you can see that currently there is no directory known as artifacts. And you can see path underscore file underscore dot parent. That means this is a particular folder. In this particular folder, the artifacts will be created. But to do what, basically? So over here, what am I doing? Output direct. I'm exporting application.json. So basically, when you want to deploy your smart contract, you need to convert that file. After the execution happens, you need an ABI file, right? A blueprint of your smart contract. And this application JSON is the blueprint of your smart contract. So these two basically, app spec.export is basically outputting the directory. That means it is creating the directory. This is just a printf statement. What is being printed or what is being done? It is just a print statement on the terminal. But ultimately, what it does is it creates a file called application.json. And ultimately, when this particular file is called build, it automatically calls itself. So this function or this function build. So basically, it will execute the function. But then this again does not deploy my contract over the blockchain. So for that, your last file is created for you, and that is called demo.py. Now in demo.py, you can see that we have imported now hello world also, and we have imported build also. So both the files which we created, now we are importing in the third file. But over here, we are able to see a new package, which is known as AlgoKit underscore utils. So in order to deploy a smart contract to a network, we will need couple of libraries. And all those libraries are defined in this AlgoKit underscore utils folder or package. So what do we need in order to deploy? What do we need? So let us just try to do that. So over here, deployment, any sort of network, whether it's test network, sandbox, or main network. What do you need in the deployment part? The first thing you need is wallet. Okay, we have that wallet address. The second thing is network address. Once you do that, these two items, then you will be able to deploy the contract. But now you need the smart contract itself. Yes, so we need a smart contract, right? The smart contract code basically. And the last thing you need sort of an ABI, which is known as application binary interface, right? So basically blueprint of your smart contract. Now, once you do all these three, this is fourth is additional, but once you have these three, then you can deploy the smart contract using the wallet over the network, right? So now let us go back to code. And in this code, we can see that first of all, build. That means our second file, which was build.py, now it is also executed. But then we have created AlgoD client. And you can see that the address is localhost, right? That is 4001. So basically, we are trying to connect with our local network. And these are the libraries, AlgoKit utils that get AlgoD client and the connection string itself. So now we are connecting to the network. Yes. Then I told you the second thing you need is your wallet address. So this is that wallet address. AlgoKit again underscore utils get local node default account from the AlgoD client. So from this localhost 4001, that means from these three particular wallet addresses which we have just seen here, these three wallet addresses, any one of them will be used, right? As a default wallet address from here. Okay, so we have the second step also. Now I told you that we will need third thing, that the smart contract code, which we already have, right? So that's why we have everything. So now I will create an application client, which will tell me which network to connect, which will tell me what exactly smart contract path is there, and which will tell me that who will sign this transaction. And now in order to register a transaction over blockchain, you need a wallet, and that wallet becomes the signer for that particular transaction. So here, the account wallet, which is by default we got from the sandbox, becomes a signer. Once that happens, your application client is created. As a next step, now we are going to deploy that. So over here, app client.create. So now using this create function, we are deploying the smart contract over the network, over the sandbox environment. Once we do that, we want the transaction ID, so we can do that, and the app ID, whatever is created for us, and the app address. So this is just a print statement which we are getting from create response. Once that is all done, what is the next step for us? That I want to call this application or this function hello. So over here, we can see that there is the last code which tells us how to call the hello method, which is deployed under the smart contract. So over here, we can see that hello world dot hello, that is a function we are calling, and we are passing the name over here, beaker. Okay, so instead of that, let's say Hyderabad. That is okay. Now over here, the call response is newer variable, and which is allowing us to call or to store the response from this call function. And what does call function do? Call function ultimately calls the smart contract function by passing a necessary argument. Okay, so this is all done. So now we have all the three files with us and we are ready to execute, right? But Mudassir, can this program executed? Yes or no? Or will this generate an error? Mudassir, are you there?
Like he's having mic issues, Sunil bhai.
Ah, okay. So hopefully Mudassir says yes, and I'll tell him no, it will not work. Why? Because we have changed the name over here. You can see that the name this is expecting is Hello World. While if you remember in the Hello World, we changed this name to this one. So we have to now replace this name from here to the second file, which was build.py. Over here also it is looking for this. So I'll change this also. And because if we have changed this one, we have to change over here also, because now the name is also different. Oh, okay, okay. It will look for the file name, not this one. So I need to change this file also. If we want to change everything, so we have to rename this also. Yeah, okay. So in the demo again, or the build, you have to change that. Yeah, it automatically changed from here. Let's see whether that works or not, or we can always go back to our hello world piece. And the demo also, okay, it automatically took learning weekend. You can see that, right? So over here now, build demo, everything is now working. Let's see our name changed, worked or not. So in order to execute that, what you can do is go to the view part over here, and you can see uh, run. Okay, so select the file demo.py, this one, which is the final file which will compile your learning weekend code, build that file, generate the ABI file, and will deploy the code over the test network. Sorry, the sandbox environment. So I'm selecting that file demo.py. I'm clicking over here. I'm going to run, and I'm clicking over here, start debugging. That means F5. You can press F5 also and click over there. So let's see whether our code change is worked or not. So you can see that the PS file activate PS1 is called dumping. Yes, it worked. And we can see Algorand AlgoKit welcomes Hyderabad. And you can see the address is also given to us, and 1003. The app ID is also created for us. So your app ID is this one, the app ID address, a smart contract address is this one, and the transaction ID is this one, right? But then I know that we have connected this to a website also. So can I see the same transaction over there? Let's see that. I've copied the data. So I'll go to my dev.flow. Sorry, app.devflow. And now we can see that there is one more app ID known as 1003. So yes, whatever we have created, it worked. And over here in the Explorer part, if I paste the transaction over here, ID, and if I press search, you can see that the transaction is created for us. And you can see the sender address, which is your wallet address, the application ID, and the block itself, in the which block the entire transaction is written. So if you click over there in the block, you can see that total transactions in this block is only one, right? And then we are using whatever the timestamp is there, and you can see that timestamp is also given to you, Sunday 25th February 9:42 over here, right? Now don't tell me that this is 11:47 and this was 9:42. Why? Because this is sandbox environment and it is continuously running. So I tested at 9:42. That's why it is showing 9:42 over here. Why? Because that image is running from that period. It is taking the Docker time, not the system time, right? So don't get confused that why the time is different over here and why the time is different over here. Clear? So this is how you can execute your hello world, right? And you are able to interact with your smart contract also with the help of AlgoKit, right? Okay, guys, now any questions? Anyone? You should have questions, guys. This is,
Guys, you can post in chat box.
yeah, you can post in the chat box also. I can answer that. Okay. There are 23 people. If you remove three for like us, but still there are 23. So, or 20
So, sir,
people.
can we use this in the payment gateways? Like we can connect this to the any website payment gateways?
Why do we want to connect with the payment gateway? I mean, for what purpose?
Yeah, to change of if we created any tokens or any smart contracts
But
using the
then this
payment.
is when you do this one, this interactions with smart contracts, this particular payment gateway is not your regular payment gateway. So the payment accepted will be on using Algo, because Algo is your primary coin in the meeting on the platform. So ultimately, what happens over here is when you deploy the smart contract, you saw that the fees was paid in Algo, right? If you go ahead and check this one, the transaction fees is paid in Algo. So over there, the thing you are asking when you deploy a token or an NFT, the payment will always be in Algo, because that's a currency on the platform itself. So you don't need a payment gateway. What you need is an integration where your Algo gets converted to your fiat currency. So
Yeah,
sort
yeah.
of an exchange or something which you can introduce. But if you want to have that ability to accept cryptocurrency as a payment, then yes. But I don't think so. There is a cryptocurrency payment gateway in India still existing, because of the government has not taken a clear stand around the use of cryptocurrency. So,
Yeah.
but you can, if you are creating wallet and all, you can. Okay, the question is, can we connect MetaMask with Algo? Yes, but not directly with MetaMask. You have to use MetaMask Snap. So that I can also showcase MetaMask Snaps. I'm not sure whether you have worked with MetaMask Snaps or not, but this is okay. If you go to Discover Snaps and you can find out Algorand and you can see Algorand wallet. And it is also developed by Algorand Foundation. So now you can manage your accounts using this one. And if you want to have a bridge token, then this one, Milko Meda. So this is also basically a bridge token which allows you to utilize your contract or your MetaMask wallet also. So you can use either of them. Somewhere here it is also mentioned about Algorand and all. Yeah, over here. So you can see that the MetaMask bridge and everything is there, right? Okay, any other questions? Mudassir, are you back or not?
Yes, sir. Sorry, there was a
Yeah, no
network
worries,
problem.
no worries. We understand. So, Mudassir, I tried to explain them the entire journey of Hello World. The wallets are created, wallets are imported also. Yeah, but important thing, one more last command is pending for me to showcase is this one. That if hypothetically I want to, let's say, okay, let us do one thing, one step more. That if I want to connect this entire thing, not just on Sandbox, I want to deploy the same code over test network also. Then what should be done? So very easy. Just follow me. Over here, what you need to do is go to Node Manager, and you will be able to see, not from here, you have to connect to testnet now. And if you go to Node Manager, you will get the URL. So this is your URL. So instead of localhost, over here, you need to replace that localhost ID with your testnet URL, right? So the way it is written over here, that it is showcasing that this is local net or local sandbox environment. You can change this to your test network environment. You can replace the code over here and you can convert that to a test network, period. How to do that? Just replace this URL, I mean to say this URL over here, and you are good to go. But no, why? Because this is a sandbox wallet, and sandbox wallets don't work with this kind of situation. So what you need a test network wallet. So what you can do is over here, connect wallet, and then any para wallet, because for Algorand, it is the MetaMask of Algorand is para wallet. So you can create a wallet over here. But the challenge over here is when you do this, since we have already added that particular network, this particular code or wallet address into a test network, we can consume this. But consume how? We need the mnemonic for the same. So how to generate that mnemonic? Just bear with me. I'll go kit whole. Then the word is address minus a, address export minus a, and the address value. If I'm right, then this will give us, no, it did not give us, okay, not address, account, sorry. So the term is not address, it's just account. And you get your mnemonic. You can see that. So here, till here to here, your mnemonic is there. So you can copy this mnemonic. And once you go back over here, instead of creating an account like this, you have to do account like this. I'll go kit utils dot get no suggestions. Okay, dot an account dot from mnemonic. Yes, over here from mnemonic, and in the double quotes you can pass the mnemonic and you are good to go, right? So your now account is created. You can just do this one. The challenge over here is this particular wallet does not have any sort of any sort of algos into that. So for that, you need to open this website, bank.testnode.algorand network, paste that address over here, and you will get 10 algos. And if you go back over here and see, connect, and go to the wallet view or view in Explorer, you can see that 10. So now the wallet has enough balance also. So now I think our code is ready to execute the same code over the test network environment. So let us just try to do that. So again, run and start debugging. Let's see whether this code now gets deployed over the test network or not. So now you think that you see that there is some time. Previously, it was almost immediate. Why? Because it was working on sandbox. So it was almost immediate. While here, it took a couple of seconds. And you can see that instead of app ID 3001, now the app ID is bigger number. So if you go ahead and over here and see the app manager, right over here, currently we are not seeing anything. But since we have created this one, see the same app ID which we have just deployed and created, now it works. It is over here, right? So now your entire application is now test network, deployed on test network. So now you can access this. If you go to Beaker Studio, right, you can see that Hello World app over here is created for us. I can create a new one, import Beaker app. I can upload the file. So from where I can upload the file, I'll just go over here, C drive. You know that we have created some sort of JSON file, right? So over here, I guess I've created directly over there. So what was the file name I created? It will be in the users folder. Yes, this one, Learning Weekend. I guess that is what we have created. Yes, Learning Weekend. So over here, Learning Weekend, then I'll go to Playground, Hello World, and Artifacts folder. I told you that we need a JSON file or an ABI file. If I select this one, you can see that the Learning Weekend is now here. I can create an app over here, or I can just write down, because since we already created an app, so instead of this one, I'll just paste the address over here, which we have created. Save. And if you scroll down at the bottom, you'll be able to see the method which we have just consumed. If you click on execute, you'll be able to see, let's say, because it's a name over there. So let's say Akash. And if I execute, see what happens. AlgoGit welcomes Akash. So this is basically a way that same code with just minimal changes, you are able to deploy on the test network also. And if you want to see the transaction, you can see the transaction over here. Right? So this is the entire journey around how to utilize AlgoKit, how to do a very simple Hello World on the sandbox as well as your test network environment. Right? So any questions from anyone, guys?
Someone asked what is the difference between testnet and mainnet.
So test network is basically your where your original money is not involved. And while main network and test network, basically you can lose your transactions. While on main network, you will never lose your transaction. It's real money involved. So you have to buy the algo tokens using your fiat currency. Then you can transact over main network. That is the difference between test and main network.
Basically, before mainnet launch, we deploy and test all our
Yes.
smart contracts and functions on the testnet so that we can verify and go live on the mainnet.
True. Okay, guys, then Mudassir, you please now take the session forward, as I'm
Sure.
already
Thank you so much,
waiting for
sir.
the other session to start. So thank you very much, guys, for your patience and support. All the best in your Algorand journey. And whenever you require any sort of support, I'll be able to help you guys. So thank you very much.
Thank you,
Now I'm
Sunil.
leaving the meeting. Okay, Mudassir, all you. Thank you. Bye-bye.
Sure. Thank you.
Yeah.
Yeah, Mudassir. Please go ahead. Mudassir, you're on mute.
I'm so sorry. So sorry. Okay. So yeah, I was talking like we have seen these things. I'm just want to give a brief all these things. So my name is Mudassir and I'm a regional ambassador at AlgoBharat and working at IIT Bombay on a blockchain project. So we have seen the evolution of internet, and after that, how the basically internet is born, and after that, the World Wide Web in 1991, when we first saw the first static website, Web 1 website, right? Netscape and Yahoo and all these websites are Web 1. These are static. We cannot basically interact with these websites. So after that, we saw the Web 2 websites, Web 2, we can say internet, where you can interact and consume over the internet. Some of examples are Instagram, Twitter, Facebook. All these are Web 2 version of internet, right? Where you can also put your own data in, but in Web 1, you cannot basically put your thoughts or anything on the internet, right? So that's why we needed Web 2. So currently we are utilizing Web 2 websites, but there's also some challenges in Web 2s because there are ownership. We don't have any ownership. All our data is stored in a centralized database, and the company basically which own that particular thing owns our data. They can't do anything, right? So that's why we needed Web3, and currently we are moving towards Web3, a decentralized internet where all your data is stored in a P2P network. P2P is basically peer-to-peer network. There's no central authority, central database. Your data is spread over the internet in a P2P network in a secure manner. So for every technology, there are a few advantages and disadvantages. Advantages are it's a decentralized. There is no control. You have ownership of your data. Security, privacy is because Web3 version uses so many cryptographic techniques, encryption methods. That's why it's secure. Censorship resistant, it's transparent. We have discussed all these things yesterday. I'm just briefing it. So difference between centralized, decentralized are user control, data vulnerability, privacy policy, and all these things, right? So blockchain, as we have discussed, you can just explain blockchain in just 4 words: distributed, transparent, immutable, ledger. It's distributed in the P2P network, it's transparent, it's immutable, and it's ledger. So, and it's based on consensus. Consensus basically manages, because since we don't have in blockchain, we don't have any central authority to command to analyze and all this stuff, right? So that's why we need some regulations, some rules, so that all the participants working on a node on a blockchain network uh, not get any malicious activity, not doing anything hacking or something. So that's why we need some consensus to regulate, basically. There are a few benefits, of blockchain: the security, immutability, trust, decentralization, smart contracts, and all these things. And we have many type of blockchains like public, private, consortium, permission blockchains. So we are basically studying the public blockchains. There are there are many public blockchains like Bitcoin, Ethereum, Algorand, Solana, Litecoin, Arbitrum, Optimism, and Ethereum, L2s, Polygon, all this. Yeah, so consensus protocol basically allow participants who may not fully trust each other to collectively agree on a state. That's why we need some regulations, right? So that everyone agrees on some particular instance of blockchain that, yeah, this is the rules we have to follow. That's why we need some consensus algorithms. And different blockchains have their own consensus algorithms, like Bitcoin uses proof of work, Ethereum has proof of stake, and Algorand has pure proof of stake. Solana has some proof of history and all these things. So proof of stake is basically miners have to solve some mathematical problems based on hashing algorithms, and then they get rewards based on how fast they solve that particular problem and add that block in the blockchain, right? And the proof of stake, you have to stake some cryptocurrency, some Ether tokens, in order to participate in the validator node. So it's 32 Ethereum, and one Ethereum is $3,000. So 3,000 into 32, that's some amount you have to stake. Stake means basically you have to lock. Why we are locking? Because if you are a participant, you are doing some malicious activity, you are adversary basically. So your the stake amount will be locked and will be gone forever. That's why we have to stake, so that no participants went malicious activity and do all this stuff. After that, pure proof of stake. So this I've explained in just few minutes. And we saw decentralized wallets like Pera Wallet, Sunil sir have shown, MetaMask, Trust Wallet, and we have also hard drive wallets for more security. You can have your USB drive, and whenever you want to sign a transaction, you can do it by your ledger, your drive, right? A smart contract, we have already executed our Teal smart contract using PyTeal. It's a Python extension of a Teal. Teal is a assembly language, transaction execution approval language, the full form of Teal. So we cannot write in assembly language, right? Because we are basically deal with high level languages. So we are utilizing the PyTeal to write smart contracts on Algorand. In Ethereum, we use Solidity. Solidity is also a high-level language, and it's get converted into some bytecodes and runs into EVM. Yeah, so smart contracts are basically used to develop some decentralized application, and it's stored in the AVM or EVM. And a smart contract is basically these are nothing but some sort of instructions, some line of codes, you can say. Like contract is basically, if I want to buy a property, I will do a contract to someone. So that contract, if I'm putting that on the blockchain, it will be a smart contract, right? So there's some instruction that smart contract runs when some certain conditions are met, some pre-built conditions are met. So the smart contract will auto execute, right? So once they are deployed, it is impossible to modify. Since it's a property of blockchain, it's immutable. If you are deploying something, it will be there forever. You cannot modify the code. That's why we need test nets, right? So that we can test our contract that, yeah, we have written everything in good flow. Everything is working fine. There is no vulnerabilities. Then after that, we can deploy on the mainnet. That's why we need test net. We have also seen a lot of cryptocurrencies, tokens. Ajay, can anyone tell what's the difference between coin and token? You can put in the chat box difference between coin and tokens. Many people just knows that these are same thing, coins and tokens. So you can write in the chat box what's the difference between tokens and coins, or maybe they can be same. What do you think? Cryptocurrencies have some properties: inability, ability to show, ability to stop, and after that we saw some decentralized application. decentralized application that runs on a P2P network instead of some central database. There is no client or server, some sort of thing, but it's spread over a decentralized network. dApps basically works on DLTs, distributed ledger technologies, and after that we saw some DAOs. DAOs are decentralized autonomous organization. So what DAOs do is, someone has written something. Coins are a form of money, but tokens can be used with a variety of purpose. Yes, this is one of the, you can say, differentiation. But there is some major difference between these two. Maybe some other person can answer. So DAOs basically we used to use crowdfunding, voting, some proposal grants, and all this stuff. So yeah, proposal execution, funding, or decentralized project, crowdfunding, or we want to some NFT-based investing, climate change, metaverse, decentralization. All these things are basically use of DAOs. Okay, let's move to this. So why Algorand blockchain, right? First of all, why we need to study this? Why we are building on Algorand? There is a lot of blockchain already are existing. Okay, let's first answer that coin versus token. Any other answers? Tokens are digital assets that operate on existing blockchain network instead of their own. That gives them some interesting probability interoperability. Okay, so the basic difference between coins and tokens are, let's remember just by, okay, coin operates in its own native blockchain, but tokens can build existing one. Exactly, this is the answer. So coin is basically utilized, coin represents currency. Token also can represent currency, right? So basically, when we are talking about coins basically are native currencies, you can say. Let's say Bitcoin. Bitcoin is a blockchain, and BTC is its native coin. So whenever we need to transaction, whenever we do some transaction or anything on the Bitcoin network, we need BTC coin, right? For the gas fees and all this stuff. And let's say Ethereum, we have Ether. So these are some coins. Okay, let's move to this coin market cap, and you can check coins versus add filters. I forgot where was that particular. No. Filter. No, algorithm. No, it was pure of focus categories. I forgot where there are the filter where you can just filter out the coins and tokens. Yeah, I got it. So these are coins, right? Bitcoin, Ethereum, BNB, XRP, and all this blockchain. These are coins. But if you see a token, you can just do this. So you can see these are some tokens. So Uniswap, basically these DEX, decentralized exchange, where you can swap, you can lend and borrow, do these stuff on a decentralized network. So Uniswap is built on the top of Ethereum, right? So that's why this is token. Uni is a token because there is no native blockchain behind the Uniswap, but it's utilizing the Ethereum blockchain, and it's the protocol built on the top of Ethereum. That's why the Uni we are mentioning it token. And ICP and all these things, like a lot of Aave is a lending borrowing protocol on the top of Ethereum. Starknet, MakerDAO, this is a decentralized autonomous organization. So these are tokens, right? So this is the difference between tokens and coins. Okay, let's move to why Algorand blockchain. Okay, so as I've already mentioned in our yesterday class or lecture, that in proof of stake, we have to stake some amount. some ether, right? So what will happen, or what can happen, that if I have a lot of ethers, hundred of thousand of ethers, and I will stake thousand of ether, right? So I will get more probability of getting my transaction done, my validation done, than others, right? So this is you can say some sort of moving towards centralization. If I have a lot of ethers, I will stake a lot of ethers, I will get more chances to approve the transaction, to validate. That's why we need some other, you can say, consensus mechanism where this is not based on some, you can say, centralized thing, where the ownership of the, you can say, the probability of getting transaction done or approving the transaction should not be like that, right? Because what if I have just 0.01 Ethereum? So I cannot participate in that network, right? I cannot be validator. That's some problem of it. So let's we can just first we have already seen this block structure where the block consists of some block number, nonce, some data, what the data it's some maybe transaction, was it or maybe you want to put something smart contract, anything. So these are some data, and the timestamp, what time we are executing that particular transaction. So this will be that, and this is ph, previous hash. We have 000 here because this is block 0, or this can be start from 1 also, and the hash of this particular block, right? And this hash will be joined to yeah. So this is 0 block, and the hash of this will be joined to this, right? ABD 1 2 3 4, something like that. So this is a chain. This is type of. And one more thing. So there is nothing like if you are doing a transaction, it will be generate a block. One block consists of thousands of transactions, right? So a block consists of lot of transactions, lot of data. It's not like that if you are doing a transaction, it will create a block and it will add it into the blockchain. No. So basically a block basically collects different transactions, and then basically it put in the block and then add into the blockchain. So this is a decentralized network. If you have, like, let's say this is my node, I have this transaction details. So other will also have the same thing. Other will have the copy of that particular blocks, right? So that if some nodes will go off, you can access. These are all are interconnected, right? So yeah, someone was asking about hashing algorithm. So let's explain this one more time. So hashing algorithm, basically in blockchain, we need some good hashing algorithm. And the properties of hashing algorithms are, these are one-way functions, these are deterministic, they're fast computation, and they will stand collision, right? So what exactly this means is, okay, let's go to the next slide. Also avalanche effect. So one-way function, as we know, like if you put something on the hashing algorithm, it give you output, and you cannot go. For example, if you have some fruits and you are making a juice, you will get a juice. You cannot go back to that fruit, right? So that's something like that. The hashing algorithm works. And after that, these are deterministic, right? So deterministic, basically, if you are using some inputs and passing it to the shadow, this is the hashing algorithm, you will get some input, right? These are deterministic. No matter how many times you put this input, you will get the same thing. So this is deterministic, and after that, fast computation. Not should be time consuming, because as we know, we are putting in the blockchain. So if it will get, if it is taking time to compute that particular hash, so our blockchain can be slow, and there may be some attacks meanwhile that, right? So that's why we need some high hashing algorithms, high power, or you can say fast, with the stand collision. Okay, so this can happen that for some two different inputs, we are getting same hash. So the hashing algorithm should be with stand collision. There should be no no same output of two different inputs, right? So this is something. Let's say James, I'm putting this hash function and it's getting me this. And for Ellen also, this is getting this. So this should not be happen. For every input, there should be different outputs, unique output, right? So avalanche effect. Okay, so avalanche, we have already seen yesterday. What exactly avalanche effect is? It's a phenomena where a small change Am I going too fast? You can just tell. Okay. So it's a phenomena where a small change in the output of a cryptographic function results in the significant change in the output, right? So that Anderson website we saw, Anderson Brown. So while we do some significant change, let's say I've written this. If I just am doing some significant, let's say just doing full stop, you can see the whole hash is changing, right? So this is you can say avalanche effect. Just changing a bit or just a number or just a space, you can see this is the whole hash is changing. So this is some property the hash algorithm while using the blockchain should have. So for this 000 hash is this, and for if I'm changing just by one bit and it's completely the whole hash is changed, right? So this is something. Coin versus token. Okay, we have already discussed nature of there are few, like when we talk about coin versus token, these are few things. On the basis of these, we discuss nature of existence, functionality, blockchain dependence, origination, and use cases, basically. So, what exactly is nature of existence? So, coins basically, you can say, represent a form of digital currency native to a specific block. These are native, right? For example, Bitcoin, Algorand, Ethereum, all these things. But tokens represent a broader range of digital assets, and often it's associated with some specific projects, like we saw Uniswap, Milkomeda, you can say they have the tokens. These are built on some different chains, right? And the specific projects or the application built on the blockchain. And after that, functionality, right? So coins primarily basically designed for use as a medium of exchange or store of value within a specific blockchain, right? But token can have various functions, including representing assets. Someone answered that, right? Or utility token, decentralized application, or anything. After that, blockchain dependence. So typically operates on its own native blockchain. Example, Bitcoin, Algorand, right? And but tokens usually built on existing blockchains, such as Ethereum, Algorand, Binance Smart Chain, and all this stuff. Origination, it often originates through a process like mining, right? Or you can say staking. That's the point of origination. When you mine a Bitcoin, you'll get BTC coin. For Ethereum, for Algorand, there are algos and ethers, right? But tokens created through tokenization process, which may involve smart contracts or existing blockchains, right? So when you are talking about token, it's on the smart contract. You created 10 million tokens. I'm taking 10 billion, all this stuff. So this is origination. And use cases. So basically used for financial transaction, coins, and a form of digital money. But tokens have diverse use cases, including representing assets or governance. You can use token governance or facilitating access to specific services of blockchain. Let's say I have 10 tokens of some particular organization, then only I can be part of that. So these are some utility thing tokens can be. These are difference between coins and tokens. I hope, yeah, understand. So let's see our consensus protocol, right? So consensus basically prevent attacks. It solves competing chain problem responsible for our block generation. Every block is generating is following the consensus protocol. For different blockchains, there are different consensus protocols. We have already seen that proof of work, proof of stake, and now we have many more. So what is Algorand, right? So Algorand is a layer 1 blockchain, similar to Ethereum, but having some different consensus protocols. And why Algorand is awesome? First of all, it's founded by MIT Professor Silvio Micheli, and he's a co-founder and inventor of probabilistic encryptions, zero knowledge proofs, and VRFs. VRF is widely used nowadays, Chainlink and all this stuff. So yeah, so Algorand is founded by Silvio Micheli, and basically Algorand is solving the blockchain trilemma. What is blockchain trilemma? It's Like there's something you cannot achieve all these three in the other blockchain, right? Security, scalability, and decentralization. If you have decentralization and you are secure, then there is scalability issues, right? And maybe if you have achieved decentralization and scalability, then there may be risk of security. So that's why Algorand just came and Silvio Micheli founded this new consensus protocol so that we can achieve all these three trilemma. We have decentralization, scalable, and secure network, right? So what is exactly pure proof of stake consensus mechanism? So this is you can say a modified version of proof of stake, or you can say more advanced secure version. So in what happens in pure proof of stake, any user can participate and verify transaction and add new blocks to the blockchain, right? There are no miners and no small groups of validators which control the network. So in original proof of stake, what happens usually, there is minimum amount of token we need to lock up, right, for a stake for a long period of time, and then only we are able to participate in the verifying transaction. For example, 32 ETH, right? But if you try to attack, your computer goes offline, you will lose your coin. So that's why we are basically locking that Ethereum. That if you are trying to attack, or maybe there's some issues in your computer, you turn off it. So you will lose your money. But in PPS, no minimum amount need to lock up. So in Algorand, anyone can participate with just one algo. If you have one algo coin, you can participate in the network, and you can use or spend your algos coins anytime you want. If you want to unstick, you can just do it anytime, right? So to participate, you just need to set up a node and then send a transaction to let the network know that you want to participate. So this is something in the pure proof of stake you have to do. So how the network choose who adds the next block? So basically it based on VRF. The selection is done using verifiable random function. If you have set up your node and done all this stuff, you have done transaction, then you can participate. And users are selected privately, right? So no one knows who is selected, and this is to prevent attack. So that it's just random. Let's say you can see that there are a few account is chosen on the purpose block, and it will be a random, and no other blocks will know who will get chosen and who will basically are getting chance to validate the transaction. So after that, a small group of participating users will find out that, yeah, I have chosen and I have won the lottery, or you can say the VRF have chosen me, and they can add the next block. So each one of them will then get two things: a cryptographic hash, or you can say cryptographic proof to the other user that they have selected, and the priority number. Priority number is basically there can be multiple users, right? So there will be a priority number which determines the priority of the user's block compared to other blocks of the networks. So this is something the VRF will choose, and after that you will get two things: cryptographic proofs and a priority number. And after that, each of these selected users will begin together some transaction. They will do some transaction and build a block, right? I've already mentioned there are in a blocks there are multiple number of transactions. So they will do transaction and they will build a block and then send it to the other computers on the network along with the priority number and that proof, right? So that other computers also verify and check, so that the cryptographic proof will be checked by others, and if they have been selected to vote on the received block, it will check basically that I have cryptographic proof. That means I am selected, right? I am not some hacker or something. And after that, group of computers will be selected to vote. This group is called soft vote committee, you can say. And after that, the selected computers will compare the priority number of the received block. Like if I have higher priority, my priority will get higher, right? And then they will vote for the block which is the highest priority to be the next block. And now everything will be good. And again, the VRF will run to select a new committee, and then the selected computers in the computer will basically check the chosen block to make sure everything is good. If there is no fraud or double spending, then it will vote on it. And basically, there are few cases. If it will found a fraud or block is rejected, or some you want to add some malicious thing, it will reject. And if the block is accepted by the committee, so it will be added in the blockchain. And this is the final thing. This cannot be removed, and it will be added in the blockchain. So this is the whole process of the pure proof of stake, using different first choosing a block and then a committee, and then it will verify this, and new committee will be chosen or certifying block, and after that block will be written on blockchain. So this is some layering of security, and don't think it will take a time, because these are done by VRFs, right? So no heavy computers are deliberating energy consumption, as VRF is a simple task. It will just run a random function from random beacon, and everything will be chosen, a block and a new committee. So this is very fast. That's why Algorand just have an instant finality. An entire process less than 4 seconds. Like, you can imagine how fast it is, and anyone who has that token can participate. No static target to attack. Yeah, so it also have some negligible carbon footprint. Also, I just wanna show you one more thing. EVM, right? So I will draw a diagram. So yeah, this is how the EVM looks like, how the codes are executed, and basically what happens here is user are we just call an application, or we have done some transaction, to it will go to the nodes, right? These are nodes, computers, and then VM executes that program, what we have sent, or we have sent a smart contract or anything. The VM will execute, and it will then again send a call to the network, and this will verify using the consensus. There are so many things between this, and after that it will add a transaction to the block, and then it will return a new block to the node, right? That everyone in that particular network should know that I have created this, and this will be added in the blockchain. And after that, the node will confirm that your transaction is done. User have made few. Like when you create a smart contract, it's a transaction, right? When you've done anything, it's a transaction. So this is the whole process, how the AVM works. First, you have send a transaction, then nodes will get to know, and it will execute a program to check all this stuff. And after that, it will add a block in the blockchain network, and then verify, or you can say send back some to the user that, yeah, your transaction is confirmed. So we have some data storage types, let's say local, box, or global. And so why these different type of you can say storage we required, because every storage have its own property and its own thing. So global and local storage are 128 byte key value pair. And let me also write here. Also, one more thing. Yeah, so just basic thing that every blockchain uses a Merkle tree data structure. This is a Merkle tree. Merkle trees are nothing but a binary tree, where these are leaf nodes. It have your data plus nonce, or all this stuff, some hashes, and then how it calculated. Then if I want, let's say for this, I want this hash. The hash of this will be hash of A and B. A and B are two its child nodes. So the hashing algorithm, basically it will calculate this hash and this hash, and this will append, and you can say merge, and the create will the final hash of this. So this is how we create a tree and put in the blockchain. So these is some basic things in the blockchain. Data structure is Merkle tree. Merkle tree is nothing but a binary tree, right? So yeah. So yeah, what I was saying. Okay. So global and local storage are nothing but they are just 128 byte key value pairs, and these are limited to 64 per contract for global storage. Yeah. So 64 per contract. You can use only 64. These are limited, and 16 per opt-in account. So if you are doing an opt-in transaction, you can use a 16 local storage or global storage. So that's why we need some other thing. If you are building some high-end application, we need a lot of data storage. So we can use box storage. So it offers unlimited of name storage segments, and in the contract up to it's 32 KB each, and we can use multiple, or you can say unlimited box storages. And global and local storage basically can be read by anyone on chain, but box storage can only be accessed by app. Because let's say I'm building an app, I need some data which I don't want other to see. Like there may be some internal data because it's my application. I just want some only some data that user should know, not all data, right? So that's why box storage is used, so that you can store on the blockchain, but this is accessible only who you want to access, right? And every smart contract creation or call is simply 0.001 algo, assuming there is no network congestion. So this is the one more thing Algorand basically provides, that every transaction you are doing, it just needs 0.001 algos. But if you see Ethereum network, let me show you. So let's move to Ethereum mainnet, or you can send the Ether scan. Or you can see directly over here. This is the latest transaction. Let's see the gas. Okay, the gas is $1. Like this is still low because I have done a transaction which costs around $100. I can show you. Like Ethereum recently, last September, October, it shifted to that Ethereum 2.2. But before that, the transaction cost was very high. I can show you. So this is also $3. But yeah, Ethereum has it costs so much gas. $3 is still it is 24. $1 is 80 rupees, that is so 240, 250 rupees, right? So this is very high gas fees. So Algorand provides 0.001 algos, right? And just few cents rupees. So this is the benefit. Okay, so uh, there is also opcode budget, as we already know. I hope most of us know that when we write a smart contract, for every line, every function, there is some gas is included, right? If you are writing any smart contract, every line that is smart contract will require some gas fees, and every calculation have some opcodes. You can also search opcodes, but yeah. So let's say you are doing plus addition in the smart contract, so it will cost some gas. It will have some opcode, and based opcode budget, basically based on that it will calculate the whole smart contract. So the more the complicated your smart contract will be, and the more gas it will cost. So that's why we need basically low retent, or you can say not very. That's why we basically audit our smart contract, that if we are doing some extra calculation, it will get removed and the gas fees will be reduced, right? So in Algorand also, it does not charge fees based on the computational cost of a smart contract call, but instead smart contracts are given overall opcode budget of 700. So 700 is a number for every calculation. You can say there are opcodes, it will calculate it. So in Ethereum, if you write a smart contract, there are opcodes, but in Algorand, the smart contract will provide some opcode budget, that you have this, you can utilize this. So that's also benefit of using the Algorand. Also, let's see something about the TEAL. So TEAL is basically human readable bytecode, runs on AVM, and it approval required, and it's single non-zero unsigned integer on the stack. And it has approx 180 opcodes, different opcodes, and transaction execution approval language is the full form, TEAL, right? So TEAL uses the smart contracts and deployed on chain by another account, and it require approval and the clear state program, as we have already seen in that thing, right? Sunil sir have shown that two programs are there, approval and a clear state program. And can be stateful, and smart signature. There are also one thing, smart signature. So these signatures kept off chain and exist as a single approval program. So this is something Teal basically utilizes. And yeah, so what's the difference between approval and clear state, right? So approval is basically main program, you can say, and it's a multiple on completion. So no effect, opt-in basically does allow local state storage to execute, and approval program also gives us ability to update or delete things. And but clear state, it can fail but cannot be rejected. There's a one thing of clear state function in the smart contract of Algorand, Teal basically. This can fail but cannot be rejected, right? And it may be called at any time, and it gives user a guarantee way to reclaim minimum balance of required and opt out of the contract. So if you're doing an opt-in to the contract, you can do opt-out using the clear state. And let's talk about some data types. So data types: byte arrays, string, raw bytes. Algorand addresses are raw bytes, right? So let me show you that Para wallet. Mm. Oh, I forgot the password. So yeah, this is my address. So this is basically raw byte, which is a data type basically. Also keys for state storage, right? These are something, some data types we have. Uints. So uints basically positive numbers. I guess everyone knows unsigned integer uint, right? So these are positive number range from to the power 64 minus 1 to 0 to this number, right? And yeah, I guess we have all these data types. And after that, I have talked about Algorand virtual machine. It's opcode evaluation one at a time, and it's manipulate the stack. And it's also responsible for read and write, temporary scratch space, and all this stuff. And let's move to our PPT. So I guess I've completed the AVM part, how it works, what are the data types, what are the opcodes, and so we have a lot of things: teal, scratch, space, and teal on completion. What happens? All these, and these are brief things: global and local storage, and box storage, box referencing. All this stuff. If you want to learn, we can do a session also, a different session. But this is a just brief session, so that's why I'm not covering all these topics. Application accounts, how to create a box, how like what storage you can put into that box storage, and how to calculate all this stuff. So these are few things. So now let's move to our slide. It's carbon negligible footprint because it does not require any high energy consumption, any high computation power, because it's based on VRF, right? So you can see over here. Kilowatt hour per transaction is 930, and here it just 0.008, negligible, right? So that's why it's carbon basically negative. So there are also some few core functionality which is built into layer 1. So what are the core functionalities? It's smart contracts, it's smart assets, atomic transaction. You can also read this. What are the atomic transfers or atomic transactions? We have also rekeying, where you can basically single public address with a flexibility of change in secret key anytime for that public address, right? So you can do a rekey, where you can divide. Basically, as we know, public key is attached to private key, right? But you can rekey over here. You have state proofs. State proof have cryptographic proof of a state that network by the Algorand blockchain itself that allows decentralized bridges and also protect this history from quantum computers, right? So if you want to bridging your interoperability project, you can use the state proofs. and we have on-chain randomness, also some standard assets. So these are a few things. You don't need to write a smart contract for that. You can just create a smart asset and you can utilize it, right? So fungible tokens for all these things, stable coins, cryptocurrencies, game points. Non-fungible are NFTs for game items, supply chain, real estate, identity, certification, all this, right? And a few core functionalities are it's cost efficient. It's 0.001 algo, which costs around this 0.0003 USD. It's scalable, 6,000 TPS and less than 4 seconds per transaction, right? And immediate block finality. Folks, you cannot fork Algorand blockchain like Ethereum. Ethereum has in 2016, I guess, there are DAO attack. You can just search the DAO attack. DAO attack Ethereum. So there was a DAO hack or DAO attack where the Ethereum chain was divided into two parts, Ethereum and Ethereum Classic, right? So Ethereum that's happened, it get forked, it divided into two different chains, and it's still there are two chains. There are a few people which are believing in the Ethereum Classic, and there are a few basically on Ethereum. Yeah, you can see there is Ethereum Classic, which is forked version, and there are also Ethereum. So in Algorand, you cannot do this. Yeah. So security, it's pure proof of stake using the VRF Falcon algorithm. Quantum resistant, that's why it's secure and low energy consumption, because we don't have a high computation requirement, right? So after that, we have some interoperability breaches, Messina, Algomint, and EVM compatibility. You can basically use that Milcom Meta, and you can bridge your algo tokens to the EVM chain, and you can write the smart contract in EVM and utilize that algo token. You can bridge using the Milcom Meta. DeFi. So why I'm showing this, because maybe you can get idea and something like that. So we have so many decentralized exchanges, Fork Finance, Tinyman, and all this stuff, Algomint, Breaches. So these are our ecosystem projects, and basically Algorand can be utilized in all this stuff, right? DeFi, stable coins. There are stable coins on the network solution. Let's say copyright and intellectual property. You can use Algo, and you can create a smart assets, and you can tokenize it, right? So this is a company that are building on that. And in real estate, there is Lofty, Pocket Properties, and these companies are on the real estate. You can tokenize your property and put in the blockchain. LimeWire, Napster, these are the music companies. They are utilizing Algorand and tokenizing basically their assets. Climate also, Climate Rate, Planet Watch, TravelX. So these are some ecosystem partners and companies. Agriculture. We have some analytics also. So transactions are this, total addresses. This is previous data. It's not updated. So yeah, more than that. And total volume logged are this. Nodes, we have this. Nodes. We have some accelerator programs also. Algorand, Miami Accelerator, Algorand Accelerate. And upcoming in the June, we have Decipher 2024 in Barcelona. And who knows, you get a chance to go there. Maybe if you are building some solution on Algorand, you can get a chance to showcase your project at Barcelona, Spain, in June. So let's build some amazing solution, and maybe you get a chance. And also Silvio Micheli will be there. So yeah. Greenhouse, this is our developer greenhouse, and you can go and basically build all this stuff. Developers tool, I have Sunil sir already mentioned all the things, building AlgoKit. building your smart contract using the AlgoKit and all the PyTeal programs. So I guess you get a idea how to start, how to build an Algorand in just minutes. So yeah, you can build some amazing thing. Also, we have AlgoGyan sessions recorded already on our YouTube channel. So if you want to if you want to build a mobile application, you can just do it using the Algorand C# SDK. So yeah, you can do that. So that's all for today. And if you want to showcase or you want to tweet, you can just tweet something like that. And if you have any questions, any doubts, anything, you can just talk. I hope have covered. I just wanted to cover everything so that you get a brief idea what exactly these things are. What are these terms? At least you know the terms. Avalanche effect. I didn't cover the BFT, Byzantine fault tolerance, because I didn't get enough time. But yeah, I hope you will read by your own self BFTs and how the Bitcoin mining, what are the Bitcoin monetary policies. There are a lot of things you can study, and yeah, there is also a book, Bitcoin. What was the book name? I forgot. Best blockchain book. Yeah, Mastering Bitcoin or Mastering Blockchain by O'Reilly. Mastering Ethereum, Mastering Bitcoin, Mastering Blockchain. Mastering by O'Reilly. So yeah, this is the book you can consider if you wanna read and you wanna go deep down, like how exactly the blockchain works, what are cryptographic techniques, and all this stuff. This is a very good book. And also there's how it is mastering Bitcoin and mastering Ethereum. So this will give you a whole idea exactly how these things works. What are that cryptographic techniques I was talking about? What are the mining things? How the mining is done, and all this stuff basically. So yeah, if you have any questions, anything, you can just can I explain. So can I explain how using POW constants BTC on mine and how PPS is used to generate algos and how it is built? So mining and validating are two different things. In Algorand, it's not mining; it's validating. It's basically in Bitcoin you have proof of work consensus, and based on your contribution, you will get rewarded. But in the in proof of work Ethereum or you can say pure proof of stake, there is no such thing of mining because we have validators. So if you are validating on Ethereum, you will get some reward in the form of gas fees, right? So these are few things in the Ethereum and Algorand have different than Bitcoin proof of work consensus. I hope I cleared.
We'll be posting on our YouTube channel once this gets edited.
Awesome. Okay, I'm going to stop representing my screen. If you have any question, we have 4 or 5 minutes. I know it's a long session. You may get bored but yeah, I hope you get to know a few new things, few new terms. And if you have any questions, anything you want to ask, you can put in the chat box. You can unmute. You can reach out to me on LinkedIn. I'm sharing my LinkedIn also.